So welcome, good afternoon. I'm Haris Hadjikyriakou from EODC, and I think I can call myself a chair of this session. Since we are a few people, we can be a little bit more informal, I guess. So the session is about C-SCALE, Copernicus, which stands for Copernicus eoSC Analytics Engine. Thank you, Sebastian. And I will start with the first presentation, which is an introduction to the project. Yeah, that works well. Okay. So a little bit of background, just to explain to you what was the motive for this project, what gap this project wanted to address. So the Copernicus program is the European Union's Earth observation program that was established in 2014 and is currently the largest producer of high-resolution Earth observation data in the world, and is planning to it already actually contributes significantly to the digital twin Earth vision of Europe. However, there is no single European processing backend to this day that can serve all these Copernicus datasets. Researchers cannot easily access a complete online Sentinel data archive, especially in a fair way. Therefore, the big Copernicus data analytics principle came as an idea. And this is what this project wants to address. It started in January 2021. It is a Horizon 2020 project, and it's going to last until June 2023. So we're now running in the second half of the project. And its vision, I'm going to read this, is to empower European researchers, institutions, and initiatives to easily discover, access, process, analyze, and share Copernicus data, tools, resources, and services through the eoSC portal. That's why we're here today. In a way that can be seamlessly integrated into their processes and research practices. We want to enhance the eoSC portal with pan-European federated data and computing resources for Copernicus, to integrate cross- and interdisciplinary eoSC services, ensuring, though, the interoperability with existing distributed data catalogs, tools and infrastructure, and therefore to increase the service offer of the eoSC portal. Our consortium consists of 11 partners with a pan-European coverage, as you can see in the map, and they consist both of partners from the EO, and when we say EO from now on, we mean Earth observation. I think I'm going to say it a bunch of times, but also from the infrastructure or eoSC world. And more specifically, from the EO sector, we have EODC from Austria, Deltares from the Netherlands, Chestnut from Czech Republic, Vito from Belgium, Cloudflare from Poland, and TUVIN from Austria as well. And from the e-infrastructure world, we have the EGI Foundation from the Netherlands, Chestnut again, INFN from Italy, SURF from the Netherlands, GRNet from Greece, and INCD from Portugal. Now I'm going to briefly talk about the objectives, the specific objectives of the project, though I'm not going to go into detail because they will be explained much more in the coming presentations from my colleagues. So the first objective is to federate Copernicus resources with eoSC computing and storage providers to deliver a wide infrastructure optimized for very large fair data handling. You can see in this graph the logic of the federation, but again, Zdenek will explain it as more of an expert in the field than me. We do want to maximize interoperability with the other eoSC services by adhering to the policies and to the operational technical requirements. And we want to make sure that the services are accessible through homogeneous and standard interfaces. Apart from the aspect of the user, so how to make the services more accessible, more easily accessible to the users. We also want to limit the burden for additional external providers to join the federation, either data or compute providers. The second objective is to scale up the eoSC portal with the federated resources, as I already referred to. And here I also wanted to mention that apart from the eoSC providers and the EO, we also have representatives from Copernicus diocese. So one of them is CREO-DIAS, so from Cloudflare, represented by Cloudflare, and VKO-DIAS, which is represented by Cloudflare and eoDC. In addition to that, we also have representatives from the collaborative crowd segment nodes, and one of them is eoDC again, and the second one, the eoDC Global Sentinel Archive and Processing Infrastructure, and from the Sentinel collaborative ground segments, we have Chestnut, GeoNet, and Vito. The third objective is to pilot the provision of a distributed online Sentinel long-term archive in eoSC. The reason for this is that Europe currently does not have a plan of maintaining a full online archive of Copernicus data. And by that, we are not referring to the cold storage, so not to tapes, because they are not adequate for long time series processing. So we thought that C-SCALE could develop a strategy for that in eoSC. And last is the co-design of the federation with relative scientific communities across Europe. So we want to make sure that what we are developing addresses the needs of the users, and that's why we started the project with 6 internal use cases, and on the go, we are onboarding external use cases through an open call mechanism that we have. Trying to collect and trying to constantly being in a feedback loop between the providers and the users. For that, we have also created a user forum to coordinate all this feedback and to enable discussions also to the outside community. And these are our key exploitable results, and I have them here listed like this because the presentations that are coming up will follow this order. The first one is the FedEarth data, is our main federation service, the Compute and Data Federation service. The second one is the OpenEO platform, which is actually a project that is running in parallel, funded by ESA, but we have enabled the access to it through C-SCALE. The metadata query service for the discovery of the data within the federation, the workflow solutions, which are the results of our use cases, of our internal use cases that we're planning to onboard on eoSC and make them available to users, and finally our C-SCALE community, so the forum, the documentation, everything that we are developing and we are making available for the users. This was a short introduction on the project, and in the next presentations we will start with the more technical stuff. I don't know if there are any questions for this, to this point, until I switch the this one, which doesn't seem to be. So Zdenek.
Hello, good afternoon. Oh, that's so loud. Okay, I'm Zdeněk Schuster. I represent CESNET in C-SCALE. I am local, so if you have any questions, not only about C-SCALE, but also possibly about Prague, catch up with me later on after the session, and we can chat. I will be presenting 2 of these services that Charis just showed you in her last slide. And the first one is the FedEarth data, which is the federation of resources for C-SCALE. I'm trying to see if this works, and it doesn't want to, so hopefully this Yeah. Okay, so the idea about federations in C-SCALE is finding sufficient, adequate resources for getting data, processing data. The idea is also not to get locked in with a single provider, to make it possible for users to shift their workloads elsewhere if they need for some reason. And to be as flexible as possible in providing the service for the same reason. With that also comes allowance in virtual access, which is European Commission's current way of funding resources that can be used by user groups to actually run some larger scale analysis of their data. I'm speaking about federations. In essence, a federation means an agreement, which means agreeing on some common ground, finding common protocols to support, exposing common APIs, even aligning each other's vocabulary, which is not always natural. So the federation in technical terms is indeed finding at least a common subset of approaches, protocols, and interfaces so that each member in the federation can be accessed and used in the same or at least a very similar way. For the C-SCALE federations, the resources that we want to federate are of several kinds. There are computing resources, mainly cloud and batch processing resources, high performance or high throughput computing, and also data resources, specifically Copernicus or Earth observation data, and mainly those coming from ESA's Sentinel satellites. Even though we are not trying to limit it to Sentinels, they are certainly the most popular ones, the ones most sought after, and also overwhelmingly those that are provided across the Federation. What we are trying to do then is to provide our users, that's the middle of my slide here, with different but standardized and widely supported, widely enabled ways of using the resources that we have. They can run their analysis under different sets of paradigms like cloud computing or some managed service platforms that are ready for Earth observation processing. They can also just access the data if they want to, and if they want to run their processing completely separately and just get the data, that's also possible. On the other hand, we also offer orchestrated platforms where users can deploy what has been prepared for them by other use cases or by experts from specific fields. They can deploy it anywhere, hopefully across the Federation. This is the picture that Charis promised I will explain in greater depth. So I'm not sure if I can do that fully, but at least for my part of the talk, we will be focusing on these blue parts here. This is what I was just mentioning. This is the different ways that users can use the services in our Federation. They can run virtual machines in the cloud. They can run containers in container management platforms. They can use interactive notebooks, and they can also use what's been preferred in terms of virtual machine images, software packages, and so on. And they can access separate types of service in our federations, cloud, HPC, or just the data. This map also has already been shown, so I'll just skip it. This is a better map. This is like segment or diagram of our federation that shows the different segments of it. The entry points, the higher level one, which are either the interactive notebooks or the open EO platform. underlying resources, be it high-performance computing resources, container orchestration, infrastructure cloud, and under that, the data federation, which provides the data that are the main reason for users to come into us and to analyze them at our resources. For accessing the resources in the federation, we try to use a common authentication approach. The idea is eventually, when all is done, to actually allow the user to kind of seamlessly, with a single identity, access everything the federation has to provide. So not only the computing resources, but also reaching for the data, transferring from one provider to the other. We are pretty close to that, at least in the cloud and data federations. And also in the notebooks, which you can access either deploy your own in your own resources on resources that you have otherwise obtained from the federation, but we also have a managed instance which is being provided by EGI, and it's kind of our preview environment that already works, so that users who have applied for access can use to evaluate the services, evaluate data access, discovery, and so on. Also, the higher level entry point to our federation is the OpenEO platform, which comes in two flavors. Either you can use a managed service that is already running and you just get access, register for access, and then you can try it out. Or you can have your own instance installed by our platform orchestration services on resources that have been assigned specifically to you. For the Cloud Federation, you can either use just vanilla virtual machines provided in the cloud. It is based on the federated cloud by EGI, so there are multiple partners. Some of them are members of C-SCALE, others should be able to provide resources if what we have in C-SCALE is not sufficient, or if for some reason someone may, for instance, want to use similar resources at their own home institute who is a member of C-SCALE. It will also all work. And the idea is that aside of simple virtual machines, there is also a set of additional tools or resources that go towards the need for Earth observation data analysis. Like we can deploy specific platforms, typically the OpenEO platform, again on your own resources, or for instance other virtual machine images with additional tools pre-installed for Earth observation analysis. The data federation, its main point is to make the data as easily accessible as possible. So we are federating under the same umbrella, under the same identity and authorization system as the Cloud Federation, so that once you are logged into the cloud or logged into the Jupyter notebooks, for instance, you can already use that identity and the token that comes with it to reach for the data. So you may know that when you are using, for instance, Sentinel data from ESA, you need to register at their site, you need to remember the password. If you are using resources, data from multiple providers, you need to register with every one of them. Remember what username and what password you used at which site, and then kind of collate it, and then you can use resources or data from multiple providers. In the data federation, the idea is to allow everybody access with a single identity token, and on top of that, it's a token that they already are using to access the compute resources, so they do not need to do anything else. You log into your Jupyter notebook, for instance, the token is already there, inserted into your notebook. You use it to reach the data anywhere across the federation. So it's the main idea for federating the data behind the compute resources. Additional services I already kind of mentioned. This is the authentication and authorization service in greater detail. It is based on standards, and it is something that is being used in the EGI federated cloud for years now. So it is a relatively well-proven service that just works. For image or software management, redistribution, updates, and so on, we use the application database with EGI. Once again, a relatively well-established service that has been in operation for years now. And we also rely on additional services that come with already being sort of affiliated with an existing federation, like monitoring or accounting for the use of the resources. Who is somehow kind of a newcomer in our area are the HPC resources. So they are basically trying to do the same. We are trying to do the same that we already know what to do with the cloud or the data. We are trying to do the same with HPC resources, which are basically clusters where the standard way of accessing the resources is using SSH as secure shell, just log in to the cluster. So we are starting from a little further back, federating these resources, but we are getting there. So the goal, once again, is the same. You log into the cluster that you selected or that some kind of auto magic suggested that you can use, and everything is prepared there for you. You can reach for the data, you have your workflow support, you have your software available, and so on. So once again, federating, trying to provide the users with the same kind of experience and the same seamless access across the federation, regardless of which specific resource they are using. If anybody wants to become a provider in any of the branches of the federation, there is support available for that. There is documentation available for that. So be it cloud providers or Sentinel or other Copernicus data providers, or be it HPC cluster providers, everybody can be shown what to do if they want to join the federation. And this brings me basically to the close of my presentation. This is the first one. 2 short status slides. So, firstly, next step. As I was saying, the HPC Federation needs a few more steps before it gets abreast with the Cloud Federation. And otherwise, we just need to polish the stuff that I have been already mentioning here, software redistribution, images redistribution, and so on, and registration in the EoSC portal. So this is something that is in progress, and it has surprised us with how complex it may be and how difficult it may be to do not on technical level, but on formal level in terms of agreements and commitments. So this is, unless I'm very much mistaken, the only service from C-SCALE that we are currently trying to onboard in the portal. But once we have learned how to do it, we will go on with the other ones. That's all for the federation part. And I may take questions because I need to switch to a separate set of slides anyway. So are there any?
Yes. What is the biggest issue connecting this cloud and the HPC for you? Where do you think this is? What is the main limitation there?
The main limitation, I would say, and I come from the cloud side of thing, is that for cloud, it's the workflow when you are a user typically starts with you logging into some kind of portal and instantiating virtual machines. And this is a process that is sufficiently supported by existing tools for OpenID Connect, for like token-based authentication. While if you are using just cluster resources, you typically do not go through a web portal. You need you use just a secure shell from your command line somewhere from the terminal, and there it is much more user unfriendly to start with tokens. It's not impossible, but you need to kind of sideline to a browser anyway just to get the token. Then you need much more user hands-on experience to be able to supply that token to your SSH client, provided that you even have an SSH enabled an OIDC enabled SSH client, right? So this is something where probably the short-term solution will still rely on SSH keys for the actual authentication, and there will be just there actually is the SRAM service that has been on my slides that will support OIDC. So you will register through some web, and you will make sure that your SSH keys are available on the machines that you want to use, and then you will use SSH keys anyway just for that access part. So it's more complex, and because users of clusters typically work from more from the command line, it presents new challenges that are just hidden from users who use the browser.
Thank you.
Perhaps a follow-up on that HPC thing, Viola. So typically HPC centers really care about efficient use of their resources, and kind of, as you have kind of a mixture of let's say HTC, HPC, whatever, how do you take care that really the HPC resources are used efficiently? So
for the time being, it is basically assured by us talking to the use cases. Firstly, we have these native use cases that are like built into C-SCALE that started with us, and when we were designing the project, we knew what kind of processing they were going to do, so we assigned those that are suitable for HPC to HPC resources, and those who are kind of in more relaxed or occasional way of processing or running something, those went to cloud or to the interactive resources. And the new ones that are coming through the open call is the same story. Like, they have their own idea, they tell us what kind of processing they want to do, what they have available, how big is the volume of their processing, and they are assigned accordingly. By the way, for the HPC resources, we certainly promote the batch processing approach. So they need to come up with large batches of data, and then they can be allowed into the clusters. So, but the first answer, the most basic answer is we know who they are. For the time being, we don't have anonymous users who just came to us and selected something without consulting. And
yeah, maybe one issue is here that all your processing is very much dependent on this large data archive, right? And the data archive is in one place only, because you now still have 4 DSs, but soon we will have only one. So the whole archive, and it's about 30 petabytes by now, is in one archive. So if you want to do any kind of, if you want to work with others that compute on that data, there has to be a transfer, whether it's HPC or some other platform, OpenEO, all these interfaces require the data to come from that archive, and be, especially if you of course want to do large-scale batches, you would have to basically transfer massive amounts of data. So how is that addressed?
So first of all, this is not completely the case, and it will show up more in my second presentation. It was kind of mentioned in the first preview presentation for C-SCALE, but the archive that we have is distributed in the sense that it's not only DSs. A lot of our members also come from the ESA collaborative ground segment, which is completely separate infrastructure from the DIAS. And the underlying idea is that everybody has some portion of the globe covered on their own resources. For instance, here in Czechia at CESNET, we run the National Archive of Sentinel imagery. So, for instance, for Central Europe, you can be covered for a completely different resource, which is ours. And there are other such national archives who are members of C-SCALE, and we hope to attract more. So the archive is designed to be distributed, and actually my second presentation will show how we try to then keep track of what's where and allow users to find the data where they are. And secondly, this is in terms of like transfer performance and transferring huge volumes of data. This depends on where users come from. So we certainly have users typically from commercial or semi-commercial or small business environment who are who have precisely this kind of care, how fast the transfers are going to be. And then there are people like us whose background is in academia, and we have no worries about transfer speeds. We have plenty. So for the time being, I would say we are actually not observing any bottlenecks in terms of not being able to transfer the data, and we hope that since this is going to be a distributed archive, not all the data will be served from the same location. Also that you will have multiple instances of the same products, and you will be able to choose where you get them. And you should also be able to choose a location to process the data that is relatively close, and the transfer will be as fast or as convenient as possible. Okay, so for the metadata query service, this is just, I think, 6 slides, including the intro one, so it will be brief. Yeah, so as I was saying, we are trying to put together a distributed archive of Copernicus data. And once again, as I admitted at the beginning of my segment, this currently mostly represents Sentinel data. We have very few data sets that are not straight Sentinel from ESA, like level 1 or 2 data and derived products of higher levels. We have already covered the federation in terms of access, how we want to make the data accessible, but of course you also need first to make the data findable. So this doesn't mean that we want to index and save somewhere in one huge database all the metadata of every product that is available across the federation. On the contrary, we try to rely on the fact that our members already know where their data are, and if there is a question from a user, they are in the best position to answer that query. So we are trying to only keep track of what our members have, and when a query arrives that can be relevant to what the user is carrying, what the partner, what the resource is carrying, then we try to forward a query. On top of that, we try not to track only what the members provide, but also what are their policies in terms of data retention. For instance, they are just a short-term archive that keeps the data for a few weeks and then drops it, or they may be on the other hand like full archives that try to keep a whole history for, say, just a small geographical area or whatever. And we also try to redistribute or contact only those who are likely to have the answer if a user has a query. So for that purpose, we keep catalog of our providers. In early slides or early proposals for the C-SCALE project, this was called a resource catalog, and it caused a lot of misunderstandings because everybody tended to understand it as a catalog of products available in the federation. In fact, it is only a small catalog of members in the federation that lists what I was mentioning on the previous slide. So what kind of data they are carrying, where are the endpoints for download, where are the endpoints for queries, and that's it. We are reusing a service that is already available precisely for this purpose from the EGI, the Grid Configuration Database. And it is a very, very small catalog of member sites in the federation. And then we mandate a common interface where each partner needs to be able to provide responses to queries. We chose the spatial temporal asset catalog, STAC, which was quite a challenge for most members in the federation because this was a protocol that almost no one at the time where the project started was supporting, but the community around the protocol seemed promising. There are a lot of tools that support it. Also, the OpenEO platform that has been already mentioned several times today supports STAC, and so we decided to give ourselves a challenge and go with STAC. So basically every member in our federation is required to provide a STAC interface or any other way of connecting with the metadata query service. So at the beginning we actually expected that the different providers in the federation will go different ways, that some will implement translation tools between their own query protocols and STAC, some that possibly will develop connectors, and only one of the possible approaches that we foresaw was that everybody, or at least somebody, will actually expose their own STAC interface. In the end, this final way where everybody is exposing their own STAC interface and the metadata query service just redistributes and collates the responses to the queries was the overwhelmingly adopted way of doing things. So at this moment, all partners in the federation expose their own STAC interface. This actually gives us a kind of advantage, and this is something that we have already seen happening in computing world. For instance, in grid times, you start with some common entry point, for instance, with a broker, but once you learn where the resources of your interest are, you can just go around it. So this service is there for you. If you are finding your way across the federation, you are welcome to use it. But once you realize who is your provider and who is probably the principal provider of the resources, in this case data, for your use case, you can go straight and you can still use the same protocol, STAC. And this also, of course, gave us some challenges, but we are trying to overcome those. Firstly, it is much more information rich than what we were previously providing, but we are coping with that. And there are some problems stemming from the fact that we are obtaining multiple responses from multiple providers, and then we need to somehow collate the response into a single response for a user. But this is also possible to overcome. So this is another service that we are providing. As I mentioned in my previous set of slides, we found that the process of onboarding a service in the eoSC portal is not as simple as originally thought. So we know where we want this service to go. It should go into the discovery category. At this point, we have not yet initiated the process, even though the service is already there. That's all for me. Yeah.
I didn't really understand your last slide. So what are you actually onboarding in the eoSC? Is it the API or is it a service which is it the GocDB kind of service?
No, it's sorry. No, it's the metadata query service. Also, it's basically the stack endpoint.
The high level one, not the one of the individuals.
No, not the individual ones.
Okay, I see.
Those could probably be advertised as endpoints to the individual partners services if they were registered in the eoSC portal separately.
Okay.
Which we might consider they probably should be, because I mean the ground segments, for instance, each of them is a valid service that should go into the eoSC portal in their own right, and where they say this is our documentation, this is our user interface. They should also add another record that says, by the way, this is our stack endpoint.
Okay, that makes sense. We are doing similar things in the Photon community. And can I misuse the microphone? The second question is, I must admit that I don't know Stack. Yeah, so we are using other protocols for metadata harvesting. Does Stack provide the keywords you're looking for, or is it only the protocol for searching? So I'm asking because is there an ontology you are using around your Earth observatory? Or can everyone kind of call them the data by themselves, like what comes up their mind?
This was I kind of skipped it, but the structure of the collections. So basically, we had to decide which subset of stack to use, and we are also still looking at extensions on the other hand that we might introduce that we are not using at the moment. So stack is a very rich protocol, and we agreed to, on, as I say, finding common ground. We agreed on some subset that we need to populate and that we need to make available to the users. And we are probably not using it to its full potential at the moment.
But you can guarantee that when I look for something for time or vegetation or something at the different endpoints, I can always use the same query. It's not like I have to know
exactly.
the endpoint. Okay.
Yeah.
Okay.
That's the idea behind the metadata query service.
Okay,
and behind the standardization. Yeah. Here's the scepter. Thank you.
Thank you very much, Zdenek. Control L we said. Down we said. Yeah. Okay. So that was the FedEarth data, the first service, and the MQS, the metadata query service, the second service. And I continue with the OpenEO platform in eoSC. Unfortunately, our OpenEO platform colleagues could not be here today because of a parallel OpenEO event, actually. But I will try to give you the main idea, although I think that Zdenek gave some pretty good hints so far. So what is OpenEO platform? It is basically a federation of OpenEO backends that provide intuitive programming libraries for the processing and analysis of Earth observation data. OpenEO platform is a project, as I said earlier, that is funded by ESA. It started in September 2020 and it will last until September 2023. So it is parallel to C-SCALE, and for the reasons that you will discover, hopefully, in the next slides, we have integrated it in our Compute Federation. Why we need OpenEO? So I will try to be a researcher for a minute or two that wants to process Sentinel-2 data. In the left side of the screen, you can see the steps that I will have to follow to do such a processing. So first, I will have to identify my area of interest. Then I will have to see what Sentinel products or tiles are available for this area of interest, let's say that for this case, I need to use level 1C. In step 3, I will have to download the time span of the data that I'm interested in. So all the files that are included in the time span of interest. In step 4, I will have to pre-process Sentinel to level 1C to level 2, so to a higher level. In the 5th step, I will need to resample it to the resolution that I need. And in step 6, I finally have created my subset of data in space and time that I need to use. Around step 7, so when I need to actually run my algorithms, I have to start thinking where I'm going to run it and how. So I have to figure out who is going to be my cloud provider, how I'm going to set up my VM. And this is when OpenEO actually comes in, where this data management burden is called here in the slides of my colleagues, is eased for the researchers. So OpenEO platform tries to facilitate this selection of resources, and as we say in C-SCALE many times, we try to let the scientists focus on their science rather on the IT aspects. How it works exactly. So on the left side of the screen, you see the situation before OpenEO, and in the bottom side of this frame, you can see that different backends have different colors and shapes, with what we want to show that they have specific characteristics that you need to be aware of as a user that wants to access this backend. And in the right side of the screen, you see that these backends are more unified, and they can communicate with the 3 clients in a common way. So with that, we want to show that the OpenEO API has created a common language for clients and backends to communicate more easily. So for example, before OpenEO, backend 1, so the red box, for example, would communicate towards the clients in a specific way, X, and the backend 2 would communicate in a different way, Y. OpenEO API enables the 2 backends to communicate in the same way towards the clients. On top of that, I forgot to mention actually that OpenEO was a Horizon 2020 project. There was a precursor project that was running, I'm not sure actually about the dates, but just before OpenEO platform. And OpenEO platform is the project that followed. So the added value that OpenEO platform brought is the OpenEO platform aggregator, which is again this federation of the providers, and now users do not need to pick the backend they need on their own. Instead of that, they have to authenticate towards the aggregator layer, and they are allocated to the right provider depending on their needs. So now we have a single entry point. The libraries that are supported in OpenEO, the client libraries, are 3. It's the R client, the Python client, and the JavaScript. If you need more information, you can follow the links. And on top of that, there's also the web editor, which is best for users that do not have prior experience with Earth observation data and prefer to work in more interactive environment. And the Jupyter Lab, which uses the Python language, which provides directly pre-installed R and Python client. For the registration, following the link at the top, you can see the plans. Basically, the plans are 3 for now. The first one is a free trial. If you're a user, you want to do a tryout of the service, or if you have a smaller project, you can try it out for 30 days for free. The second one is to be an early adopter, which is sponsored actually by ESA. So there are costs, but they are covered by ESA, and this is for free for 90 days, for 3 months. And if you have a bigger project in mind, and you need multiple licenses, then you can go through the network of resources to book multiple licenses. The network of resources, for those that are not aware of it, is an ESA initiative to facilitate the use of cloud environments by users, those that have R&D projects, but on commercial platform resources. So is the tool ESA uses to cover the costs on the commercial providers for R&D users. As you can see in this schema here, OpenEO platform can be accessed both by the network of resources, but also by C-SCALE. And you can either be a user, but also a provider. So you can use OpenEO platform, but you can also become one of the OpenEO platform providers. And I also wanted to mention here that C-SCALE, to me, at the beginning, honestly, let me be honest for a second, it was a little bit confusing because we're talking about 2 federations, and it was a little bit confusing to understand what is the difference between these 2 federations. But actually, as I learned more about OpenEO platform, I realized that C-SCALE just covers much more, and OpenEO platform is just a part of it. So I just wanted to share this realization with you. OpenEO platform will be onboarded as a service under the workflows until the end of the project, but can be used already now through the federation. And I believe that was my last slide, together with how you can join the community, where you can find the documentation, and where you can post your questions and get in touch with the OpenEO experts, actually. And I think that was really my last slide. Yeah. Are there any questions? No. Your favor? Yes. Okay, thank you very much. Then Sebastian continues.
Hello, everybody. So I'm Sebastian. I work for EI Foundation, and I'll be talking about the 2 remaining services. One is the workflow solutions, and the other one is the C-SCALE community. So I'll start with the workflow solutions, and I'll give you just a very high level about workflows. These are a set of steps to process data and take meaningful outputs and figures, interactive maps from raw data. The way they work is that you can make them configurable and reproducible, so you can reuse them. So you have the same workflow working for different areas of interest and different time periods. And the goal of the C-SCALE workflows is to provide tools for monitoring, modeling, and forecasting on the Earth system. The workflow solutions in C-SCALE have been provided by the C-SCALE use cases, and I'll be presenting those as well a little bit. So as Haris mentioned before, the C-SCALE users help co-design the C-SCALE infrastructure because they test the usability of the platform, they derive new user requirements, and they keep us providing feedback during the whole project, so we can put that feedback into service providers and then fine-tune the federation to better help users. I'm going to present here a very brief and high-level summary of the 6 use cases that were identified in the proposal stage. And those are the acronyms for the use cases, just to save some time. So it's Aqua Monitor, Water Watch, High Sea, LSDA, Return, and Wetland Water Stress Analysis. And some of them already were developed before the C-SCALE project started, so they had a more mature kind of TRL before C-SCALE started. So the goal with C-SCALE was to port the same workflow from a different infrastructure into C-SCALE and see what we can learn from porting the workflow in the infrastructure. So I'll start describing the use cases now. The first one is Aqua Monitor, and the goal of this use case is to track the changes worldwide when the land becomes water and water becomes land, and for many reasons. So the result of the use case is at the moment is a Jupyter notebook that's open source, as is publicly available, so others can learn how to do the same thing, but using OpenEO. And you have the link to the repository over there. As an output of the use case, here you see there is a plot of the world where there are blue and green pixels, and the blue pixels represent changes when land becomes water, and the green pixels represent the changes when the water becomes land. And actually, you can go to the URL and have a look, because this is an interactive map. You can play around, zoom in, zoom out, and find out more information. The next use case is Water Watch, and the goal of this use case is to basically provide high quality information about water availability across thousands of reservoirs worldwide as well. This is just a screenshot of the news item published in the C-SCALE website. And again, here I show you a screenshot of a map. You can again go to the URL and play around, because it's also an interactive map. You can again go to the region of interest and find out more information about specific reservoirs. Then the high sea use case. The goal is to model hydrodynamics and water quality in coast zones. For example, providing services for aquaculture industries, doing forecasting in terms of oxygen concentration, seawater temperature, sea currents, and waves. Also services for ports, providing early warning systems for abnormal parameters in the quality of the water, and also identifying the source of contaminating sources in nearby areas. As an example output of the use case, you see the Saronic and Argolic Gulf in Greece. On the left side, you see the probability of the water temperature not exceeding 15 degrees Celsius for March 2018. And you can see that the Saronic Gulf is more likely to not exceed that temperature. Whereas on the right side, you see both of them again, but this time is August 2018, and it's the probability of exceeding 26 degrees Celsius on both. And you can see how both are equally likely to exceed that temperature at that point in time. So then we move to the LSDA use case, and the goal of the use case is to provide forecast for seasonal reverse discharge, and this is because, with recent droughts and water use increasing, we kind of want to have a prediction of water availability and river conditions depending on the season. The return use case tries to quantify what's the capacity that have tropical forests to recover from droughts or human exploitation activities. And so, for example, you see in this picture 3 areas, South America, Africa, and Asia, Australia, with those pixels in green and red meaning that it is less likely for that area to recover and go back to normal conditions. And again, you have a link to find out more information about the use case there. And final use case is wetland water stresses. The goal is to go worldwide and identify those wetlands that are healthy, meaning those that are permanently humid and saturated with water, because basically when the wetland is healthy, they are a methane sink, but if they are stressed, they become a methane source. So the goal is to identify where those are and elaborate or kind of inform policies to protect them appropriately. And this is a sample output because of an RGB composite capturing the dynamic of the wetland. The goal of the use case is to develop a classification model to classify healthy and unhealthy or stressed wetlands across the world, but also to improve existing models with more accurate data-driven approaches. And this is one example of a workflow from the High-C use case. You see there are several steps in the workflow. The first one is to download the appropriate data to the infrastructure. And then there is the pre-processing. This is basically preparing the data for the model that's going to run in the following step. And that's the Delft 3D model from Deltares. In the workflow, they have been running the model on the cloud, but as a next step, the goal is to run it also on an SCC facility using the same workflow. And then at the end, it's just the post-processing is putting everything together in a nice way to be presented and plotted in a figure. And here I present a summary of what are the challenges that the use cases bring to the table for the C-SCALE infrastructure. And for example, for High-C, as I just mentioned, the goal is to test the interoperability and scalability between cloud and HPC resources on the one hand. AquaMonitor compares performance accessing both local and remote object storage. Return is trying to create interoperable, scalable data analysis-ready data cubes. WaterWatch is quantifying the time that delays in accessing Sentinel surface water area from the different ESA data hub relays that are participating in the federation. LSDA performs is comparing the performance and scalability of both again cloud and HCC resources. And finally, the wetland water stress is trying to basically compare the performance of running the analysis where the data cube is hosted on a single infrastructure versus the case where the data cubes are distributed across different data providers. As we mentioned, the intention is we are going to upload the workflows from C-SCALE in the EOS marketplace, and this is the right category to go into. So yeah, it's an ongoing process. And now I have completed the presentation about the workflows, and now I switch to the C-SCALE community. So basically, this is to explain how you can become part of the C-SCALE project if you want to. So we have created an open forum where everybody can go, and you only need a GitHub account. But basically, this is open for discussion for everybody. We also share some news inside the project, like events or training sessions or questions in general about how to perform certain steps. But anybody is welcome to join and discuss and participate. We have also put together a set of documentation pages where we try to capture the getting started guides for both use cases and also service providers. And the idea is to improve this as we go along, basically capturing the feedback from the use case in the problems they face, and just documenting those in there to provide a more efficient user support. Then we also do training and support, again using GitHub. For every use case, we want to create a repository, and with this feature, GitHub projects, we can create Kanban boards so we can track progress of the use cases, and also use cases can submit questions on how to perform certain tasks. We can engage with them from the project to help them achieve their goals. we are also very proud of some of the members writing down this nice article explaining what C-SCALE is and what it offers in the Big Earth Data Journal. And then, yes, we are very happy to disseminate the word. So every time they publish something or they create new tools or services, we are the channel to promote that out loud. That's why we also have a dedicated section in the C-SCALE website where you can find all the news relevant to the events and the use cases and so on. And finally, there is an open call for use cases. So everybody is welcome to apply for resources. And then there is a template that people need to fill, specifying what they need, what they want to do, what resources they need. So basically, the way it works is that we receive the application, we do an admin check, and we also check how aligned it is with C-SCALE goals. When everything is good and clarified, we then circulate the application with C-SCALE providers, and we let them kind of jump in to offer their resources to support the use case. And then we get together in a meeting and try to do the allocation of all applications to all providers in a fair way, so everybody gets use cases to support. And then after they have been onboarded, we like to have kind of follow-up meetings every now and then where we keep an eye on the progress of the development and the deployment, and try to capture their feedback, improvement for suggestions, and if they need help, if they need more resources, etc. But not also, we have the open call. There is another channel via the Digital Innovation Hub where SMEs can also jump in and request access to C-SCALE services. But not only as a use case you can become part of C-SCALE. If you are a cloud provider, you can join CESNet, Cloudflare, UDC, GRNet, INCD, INFN, or Vito and become part of the federation. If you are an HTC, HPC provider, you can basically join SURF, GRNet, or Tubin. And if you are a Copernicus data provider, you can also join the data providers in the C-SCALE Data Federation. As Zenek mentioned, there is support, documentation available, so you just need to approach us. And just to give you a sense, we don't have only the 6 use cases I mentioned in the previous slide. Those were identified in the proposal stage of the project, but through the open call and through the Digital Innovation Hub, we have already onboarded 4 new use cases that you see on the top. But also recently, we have started onboarding the 6 new use cases that you see at the bottom. And again, the idea is that we are welcoming more people to apply for resources. We are happy to have you on board and provide support to deploy your use case. And that's it from me. Thank you. Any question? Yeah.
I was trying to remember, it was 2014 that Sentinel data became publicly available in general, but those use cases, are they finding the limitations, like finding resources prior to that year, 2014, or do they have alternative data provided by ESA?
I
don't know, just a general question.
I think that the ones that are working with Sentinel data, they just don't examine the period before Sentinel data was available. And we mainly, as Danik said earlier, is that true? Because you gave me a look. I want to say, what did I want to say? I lost it. Do you want to add something?
Yeah, so my question was specifically like those use cases that who are participating, did you get any feedback, when it comes to limitations to their services? And because users might just come up with this challenge of finding the resources. The service itself might be really functional and then usable, but yeah, when it comes to data availability, that might be the real neck.
So for the time being, the use cases that we have, and certainly those that have been with us from the beginning of the project, they are pretty knowledgeable, so they have a good idea of what data are there. We didn't have anyone coming up and saying, oh, I thought you will have Sentinel data from like the 80s. So in that sense, we have been pretty fortunate that we had knowledgeable users who knew what could be provided. Some of them had to be, their expectations had to kind of be adjusted because many come asking for Landsat data, and that of course is a problem. So we are not like shying away from Landsat data, but actually we have very little hands-on experience with redistributing those or even caching those. And they are relatively low on our priority list because they are not even Copernicus data. Right. So it's like Sentinel is the top of the list in terms of interest and also in terms of our expertise. Then there are other Copernicus data, so European produced data mostly, and then there are data from other parts of the world. And even though we would like to get better acquainted with this, we need a good incentive, which means on one hand capacity to do it in terms of effort, and also a user base that will work with us. And the best case is that they already have some expertise themselves and they even teach us, because this stuff outside Copernicus and outside the European space we have relatively little experience with.
Okay, that's good to know. That's the state of the art, right?
Yeah.
Okay.
Yeah.
Excellent. Thank you.
Sure.
If not, who's speaking now?
It's me again. So thank you, Sebastian. We have a quarter left. So in this quarter, probably less, so that we can allow some questions. I wanted to briefly present our sustainability plans, which is, as Denek mentioned earlier, it's a hot topic, especially in the second part of a project. And basically, this, our sustainability plans are around the key exploitable results, which are the 5 ones that we mentioned before. Let me not repeat them. A few words on how we identified them. After the project started and we started gaining a better idea of what from what was written in the proposal was actually feasible, was the most useful, we started forming a better idea of the key exploitable results that we want to promote the most and to exploit the most. And these are the services that you heard already and our community, the C-SCALE community. For these 5 results, we identified the target groups, we identified the value that they add to the target groups, and also we clarified how far we want to take them, so the current and the future developments. To exploit these results, both during and after the project, we can either, according to the grant agreement, we can either use them in further research as products in services, or to use them to define standards. And these 3 boxes in the middle of the page show you some examples of non-commercial, commercial, and standardization activities. So, for example, in non-commercial activities, these results can be used in further internal or collaborative research in the academia, in policy making, and in open science. In the commercial world, they could be used to create a product or a service as part of industrial research, so with a pricing model. Again, in the collaborative research area, and they could even lead to a creation of a spin-off. In the standardization activities, they can contribute to defining standards or adopting standards, and to the open source community. So, as C-SCALE partners, in order to define our sustainability plans or our sustainability goals, we have to ask and answer mainly certain questions that you can see at the bottom of the page. And these have to do with the ownership, with the access mechanisms, with the maintenance and support, with the costs, and with the return, so the revenue streams that are expected. And here we wanted to present you briefly the status of our plans, basically. For the first service, for the Fed Earth data, we're planning to make it available to the users through the eoSC portal, as it was mentioned, through the onboarding to the marketplace, but also through C-SCALE, so through contacting directly the partners, the C-SCALE partners. What it depends on, this is actually the availability of the providers. So currently the C-SCALE Federation consists of 11 providers, actually no, 8 providers, the other 3 partners are users. But it's not certain yet who of these 8 providers will be able to commit to the sustainability plan. For that, we are trying to set up some letter of commitment, MOU, some OLA in the future, anyway, some relationship that shows some commitment for the future from a certain provider. The second one is the metadata query service. This is openly available by public URL anyways, but it will also be onboarded in eoSC portal. It seems that I forgot to mention it here. This again depends on the availability of the providers in a similar way as with the Fed Earth data. The OpenEO platform will be the same way, available in the marketplace and through C-SCALE. Of course, as we said, someone can access OpenEO platform through the OpenEO platform channels and the NOR, the network of resources, but in this way you are not part of the C-SCALE Federation. You cannot use the data that the C-SCALE Federation offers. You just use what OpenEO platform uses. But that's a different story. In C-SCALE, we will make it available through the marketplace and through contacting the C-SCALE Federation. The workflow solutions will be published and available on the marketplace, but also on the AppDB. And there is open source. They are going to be open source along with documentation. And finally, the C-SCALE community is open by default because it is the website, GitHub, Twitter, documentation pages. It's all open URLs. It's going to be maintained. We are discussing that it's going to be maintained by key partners depending on the demand and depending on the needs, of course, of the users. And this is basically it. This is, of course, a work in progress, and the more the time goes, the more we understand how this is going to work. But this is the status. And now I think we have some time. We have like 9 minutes for either questions on the sustainability or of any kind, or any topic.
Yeah, thanks for these very nice presentations. You mentioned a couple of times that you had kind of friendly use cases. So use cases who really know already what they are doing, what they need, where they should go perhaps, where the data is. Assuming that this might change later on. So you have now these, let's call it them friendly, no? And perhaps now these more complex things. Users not really used to this kind of platform. I wonder kind of if you really need more support, for example, to bring them into this kind of infrastructure, and regarding sustainability, it may become expensive.
Mm-hmm. Hello.
So this is really interesting because there are several types of users, and it basically depends on what environment they are coming from. So I would say users who come from the environment around ESA, like the ESA Sci-Hub, they are content with anything. They are happy to be, they are happy basically that the data is there and it can be accessed faster than normal. They are willing to learn new stuff because they had to learn new stuff in the first place to just download the data and process them. And they are even happy to keep their own workflows and just get a better data source. And then we have users who come from other complex environments, and they have already made a significant investments into learning, for instance, Google Earth Engine. And now we tell them that they need to learn a completely different thing, which is OpenEO with some other data federation in the background. And these need much more, I would say, assistance, much more being led by the hand. So far we have had time to do it, and we hope when we are done and when we no longer have time and resources to do it, we will at least distill some pretty good documentation based on our experience that will hopefully help the user if we are not there any longer to help them ourselves. So this is how we have been doing things in EC related projects for years now. So I don't see how this can change.
So far, this is covered by virtual access, this assistance.
The virtual access covers primarily the cost of the resources themselves, but also covers partly the people who take care of the resources, and certainly they are there to help with the computing infrastructure side of things for stuff that is more user-oriented and like focused more on the expert part of the process, like actual software for processing satellite imagery. That's more the stuff or the funding that we have for C-SCALE.
Is there any other question? We still have 5 minutes, if so. We didn't mention also that Guido is one of our users.
Yes, I'm sorry on the fly. But
yes.
No, but I mean, since you were talking about planning in your last slide, so I think what is very important is to realize that we are now moving to a completely different setup. So this new DAS that's coming, should be signed actually this month, is going to be one big consolidated platform, a single provider, which combines the Open Science Hub, so that will also disappear, will be merged. So you have one entry point for people that want open data, says download an image here and there, whatever, up to the full HPC user who wants to process the world. And to be honest, if I look at your use cases, most of them have a global scope. So I don't think that is easily addressed by what Senek said is, the Czech facility or the Greek facility or veto the Belgian facility. So I think the tendency is to move to this big platform. So I think this is how you should probably also plan what your next role is in that. And I think the educational part is very important because we have realized that it is a big, whether it's OpenEO or doing things at bash level, that doesn't really change a lot, or even Google Earth Engine is not something that is easily done from the start. So all this stuff requires a certain education, and that is even more difficult if you're not talking to scientists, but to say public users that need to use it in, I don't know, common agricultural policy and the stuff that we're dealing with. So I think in many of these efforts, the educational part is always underestimated, and we find that to be the key part. So you have to come up with simple workflow. I mean, the workflow part I like a lot because I think that is exactly how you should approach it, to formalize each, whether you do it on your local platform or you're on your cloud platform or on HPC, that you can work with your same workflow and you can just sort of migrate on the basis of your needs. So I think that's something that really requires much more attention. And I know that in the conference there are a couple of sessions on skills and education. So that's definitely something I'm really interested in as well, to understand how that is developing.
Mm-hmm. Thank you very much for your comment. Yeah, I don't know if you would like to add something. Or you're good?
No, I'm good.
Okay, thank you, Guido.
If you allow just another comment. So in your introduction, you mentioned FAIR.
I did.
FAIR principles. And I listened to all these presentations after them, and FAIR wasn't mentioned even once after that.
Mm-hmm.
So why?
Yeah.
A bit astonishing.
So one key here is that C-SCALE, if you exclude the use cases, C-SCALE does not produce data. The only data that are produced are through the use cases. This is still, let's say, it's in our last. I'm losing my English now. I'm sorry. In the last part of the project, we're planning to really think about the data management of the use cases. So far, we were focusing on porting the use cases, solving the challenges with the federation, rather than dealing with what is going to happen with the data that they're producing, simply because they were not producing data yet. Now that they are more mature and they will start producing the data, this is definitely one of our priorities, to see how this data will be fair, if that satisfies your answer.
May I also add
of
something?
Course.
So I kind of, it doesn't come easy to my lips, the abbreviation FAIR, but if you think about what we are presenting, it was there. I mean, the metadata query service, it's about findability of the data. The federation for access, not only to compute resources, but also to the data resources, it's about access to the data. So all these principles are hidden in there. We just do not think, at least when I'm preparing slides, it just doesn't come to my mind to mention it's fair or fairness or more fair or whatever, but the principles are there.
Pierre Sidaner from Observatory of Paris. We have in the observatory in astronomy a lot of projects that use a kind of science platform plus a system of data discovery. I see that you have all the elements of it. And the problem for me is to go the right way. I mean, they have to be able to perform science in platform in many different places, and to have access to the data from also many different places. And each project have its own background system. It could be Rusio, it could be iRods, it could be whatever. And it's quite difficult at that time to see where to go and where not to go to be sure that on the next day you can move your science platform somewhere else on another compatible system with notebooks and so very classical things. But we don't see yet if it's easy to move from one place to another, looking at everything you have proposed to something else based on Rousseau, typically as not C systems. Do you have any comment on that?
So I may have. Firstly, the world has moved a little. So nowadays, the technologies that we use, like containers or even virtual machine images, they tend to make things more repeatable and more portable to different resources. The other thing that is actually an advantage of liaising with a large federation like the EGI is that the EGI actually does this kind of exercises from time to time, that we try to show, or they try to show, that it is actually possible to take a workflow or take a use case and run it at another provider. And if there is some kind of issue, they try to smooth the edges across the whole federation so that this works better next time. So we may not be there yet, but this is something that is getting attention. It is being tested from time to time, that it is actually possible to move the computation elsewhere, and there is at least promise of that. We cannot make the world perfect in one go. But we are trying.
We're past 4:30 anyways. Maybe people want to grab a coffee before the next session starts. Is there any last question?
So I'm Pascal Floor from DANS, but actually my question relates to when I used to be a user, a researcher using remote sensing data. So this is before C-SCALE existed, which is a shame because it would have been very useful. But I used to use Google Earth Engine, but I used to download data from the US Geological Service. Mm-hmm. And I was just wondering, and it might be a very ignorant question, so it's been a while that I was in there and that, so how does it relate? And I was just reading, I just checked on their website, and they're going to stop doing Sentinel data and are now referring back to Copernicus. I don't know, how does the different resources relate, and is there any chance of them being integrated somehow? I mean, I know this is Europe, EU, and there are US, but I don't know, as a researcher, I from a researcher point of view, user point of view, I would, the more there's one single point of entry, the more useful I can imagine. But so I don't.
Do you want to take this?
Any thoughts?
So in this case, I'm no expert. I myself come basically solely from the ESA collaborative ground segment background, and all these other stuff is just my observations. So according to my observations, Europe has its hands full with at least getting the Commission and ESA together, and as far as I know, there is no activity to also bring the US on board. So I would say the US products will always be used separately or in a different way from the European ones. And for ESA and the EU, it seems that ESA on one hand happily does what the EU orders or what EU asks for, as long as it also pays for it, but it prefers to also keep its own solution, like the ground segments, for instance, alive, because it needs it for its own members, which are like there is not one-to-one relationship between ESA membership and EU membership. So it seems to me that different systems of presenting the data, making the data available, or redistributing data are there to stay for quite some time, even in the European space. My personal opinion.
We were thinking, though, to integrate Landsat data if there is enough demand by use cases in the data federation. I think you also mentioned it earlier. Yeah. But somehow how it went with the use cases, it showed us that they could live without it. They found an alternative within Copernicus, so it didn't become a strong need. That's why we didn't do it. But we were thinking about it, and it's still on the table. Let's see. Thank you.
So one thing, once again, my personal comment, right? We have been entertaining you here for 1.5 hours, but C-SCALE is actually a relatively small project. So we don't have much power, and we have pretty ambitious goals. So we didn't actually have much effort to go beyond what we originally planned. And Landsat is, on one hand, relatively low-hanging fruit. On the other hand, we have not been able yet to really try and incorporate it. So optionally, when we get there, or possibly after C-SCALE, we may have enough effort available to try and include Landsat, at least as a kind of preview, but we have not been able to do it. And as Charis said, the use case is scoped, and they told us it's not that essential. So it's not yet available, even though we know we want to try, and we know what we would do if we actually went and tried.
People will hate us by now, so let's close. Thank you so much for joining, and see you around these days. Thank you. For whoever is interested, we have some flyers here. Maybe you could have the links and the website and stuff in a hand.